Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning experience brought to you by Cloud Native Now. My name is Cody, and I'm the host of Techstrong Learning, and we have yet another exciting panel today. But before we get things kicked off, I do have just a couple of housekeeping notes I'd like to review. First off, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend, the on-demand recording will be sent to you shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of ways for you to do so. The first of which is the chat tab. If you look to the right side of your screen, it will be the first option you see. I'd like you to start warming that function out for us right now. Let us know where you are joining us. If you do have any questions for our panelists today, we do want you to direct those to the Q&A tab, as that just helps us keep track of your questions a little bit easier. And as always, before we close out, we're going to be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our conversation today. So our topic is container networking, and I'm joined by Frank J. Olhorst, editor-at-large, and Mike Vizard, Chief Content Officer here at Techstrong Group. Frank, Mike, thank you both so much for joining me. Mike, do you want to go ahead and get this going?
Sure. Thanks, everybody, for joining us. I guess I want to get started with a little bit of perspective on when does container networking get hard? Because if I look in, say, for example, inside of a Kubernetes cluster, right? So the pods kind of communicate with each other, and there's kind of some built-in networking capabilities into the cluster, and that's kind of cool. But once I get to 2 clusters, what happens? Do pods need to talk to each other across clusters? And that's a little more granular. What makes all this stuff different, and kind of do we need to change the way we think about networking in the age of Kubernetes?
Definitely. It's funny how you say, what makes it hard when, it's always been hard when it comes down to it, as they, introduce new capabilities and expect more out of containers. But I'm thinking where, the biggest challenges come from is when you start doing those large scale deployments. And this is what's going on in the enterprise all over the place. They're increasing the number of containers, the number of services related to them. And then you start going into, an issue where you have to kind of, manage what's going on between those containers, how they're talking to each other, balancing loads, checking, what the network performance is, validating the reliability. And that becomes exponentially harder as you, as you try to do a large scale deployment. Another thing that, really complicates it is these, multi-host environments where you're kind of distributing your containers across multiple nodes in a network. And how do you make sure that remains consistent, not only with policies and security, but also with performance? The list goes on with all of these challenges that make managing containers pretty difficult. And, I think people take it for granted that they're like, okay, you throw up a few containers, they're easy to manage. Oh, if we add more, it'll be just as easy. It's just like adding another kid to the family. Yeah, it'll be easy, but we all know that's not the truth out there.
I don't know. Some folks, they keep adding kids anyway. But to your point, I think one of the issues is that the containers themselves are ephemeral, right? I mean, compared to a virtual machine, which kind of is a stable thing that, once you set it up, it sits there and it looks for these network services to invoke, and, things don't change all that much. The average container lives for a minute, maybe, if that. And so, but every time it gets spun up, most of the time it's being replaced by something that looks just like it. But at the end of the day, there's a tweak to it somewhere, and it's looking to interact with something that looks like a network somewhere. And that's where the challenge seems to be. This is a highly dynamic environment, and I'm not even sure that the way we created networking in the first place was even designed to address it.
Yeah, that's very true. I mean, the way that networking was designed was kind of for resiliency when it came down to it, especially TCP/IP. It's all about that resiliency, multiple paths to make things happen. But the premise behind that, goes back to the birth of the internet. It was, okay, how can the military keep talking to each other during a nuclear war? That's really where it comes from. So fast forward 60 years to where we are today, and we're still kind of hindered by much of that. How things are routed, how things communicate with each other. And we wind up with these situations where we can't ensure network isolation to keep things much more secure. And that is also one of the challenges with containers, especially how they're living out at the edge. How do you isolate certain things to keep security at a high enough level that you don't have to worry about containers becoming part of an attack surface? Now, you look at a lot of the add-ons or the components out there, or you delve into things like, Docker Swarm or Kubernetes. There's always hooks in there for, to improve security or observability and elements like that. But it still does come down to having that ability to monitor what's going on, not only what's going on in the network, but how the containers are communicating, the loads that are placed on them, how traffic is moving. And you can't do that in a vacuum. You
Mhm.
have to have this information presented to you. And that just adds again to the complexity. And while we can look at specialized container networking tools like Calico or Istio or ones like that, then again you're adding another level of complexity trying to solve complexity. So it turns into this kind of giant ball of yarn that you're trying to unravel and figure out, how you're going to knit the sweater out of that.
Mhm. It almost seems too like there's a lot of moving parts, right? And not just the containers themselves. We got proxy software, we got ingress controllers, we got API gateways, we got network virtualization platforms like Calico. And I think the average organization gets a little confused about what to use, when, and where. So, is there any kind of rule of thumb for what you need versus what you might need down the road, or is there some sort of gradual scale of things that I need to use as I go along, as I go from 2 clusters to 10 to 100?
Well, you can look at it the way of evolving it from, looking first at, proxy software. You look at what like Envoy can do and how that can handle your load balancing and your proxying and your traffic routing and those type of elements that are so critical to containers. But also, people have to be able to get into the container. And then you're looking at something like, adding an ingress controller to the mix. And let's say you're running Kubernetes, for example, which works great um, internally when it comes down to. But once you have to start, managing ingress from external traffic, it gets a little bit more complicated, and that's where you start looking at Contour or traffic or what's the other one, Nginx, those type of things. So this all kind of leads us to a conclusion, I guess, of where you really have to get your arms around how a service mesh is going to work and
Mm.
how you're going to be able to integrate and pull all these microservices that are created by containers together so that you can do traffic management, you have observability, and you can deploy better security, hopefully at the application level. And it brings consistency to the mix. So I would say when you're starting off with a couple of containers, proof of concept, and you're looking at, you want to scale to something larger, you have to look at that whole idea of trying to minimize complexity, enable observability, and have a unified approach to how you're going to have people ingress into your containers. And making all these things work together can be a challenge, but the tools and things are getting a lot better.
Well, I'm going to come back to that question in a minute about getting better because I'm not sure I'm seeing that. But one of our attendees wants to add another solution into the mix and is basically saying, what about IP VLAN and Mac VLAN with rootless Docker containers? Is that something that you've seen people do? I don't know if you know much about it because there's a lot of nuances and a lot of different use cases, but it seems like um, there must be 100 different configs that I could come up with involving various container networking things. So, what are you seeing or hearing, or anything in particular working more so than another?
There's a lot of interest in IPv because it echoes back to the whole idea of building virtual networks, for lack of a better term, thinking of it from a VLAN, a virtual local area network. IPVLAN is bringing forth kind of that ideology to help virtualize the networks that are being created by containers, or allowing you to much more easily network containers together. And there's a lot of interest, and a lot of folks are talking about that, but I haven't done anything hands-on with it to really give an opinion if it works well. But the whole idea of being able to have more control over that networking plane is very attractive when it comes to being able to scale containers.
All right. I've lost track of the number of proxy tools that there are for Kubernetes, but I think they come in various sizes from really super huge to, extremely small and lightweight. Does size matter with these proxy tools? Because some of them are, as complex, if not more complex, to deploy than Kubernetes itself.
Actually, size does matter because the larger your container infrastructure is, the more things that you might have to worry about. And the way I'm talking about that from that point of view is that, let's say you have a container, your container is distributed across, multiple hosts, or things like that. Putting a proxy around it helps to make it more manageable. But on the other hand, there's so many moving pieces and so many moving parts. You better know what you're doing. And what I'm seeing out there with a lot of these, proxy software folks that are offering, their particular solutions, is that, hey, it does everything that you need, but they don't really define what you need, nor do they give you kind of that, quick start approach around it, because there's so much variation. So there's a bit of a learning curve, and you're going to have to rely on folks to really be able to help you, set those up and manage that, especially with how rapidly some of these technologies are changing.
Mm-hmm. Is this something you would do yourself, or is it increasingly going to become more of a managed service that I rely on somebody else to do? Because, finding good networking people was hard enough in the day. Now I need, a networking person who understands containers, and that might be one in 50,000.
And they're in demand. And you look at the shortage out there in the corporate world of having people qualified to do certain things. I mean, you could use cybersecurity as a real good example. Everybody claims to know cybersecurity, but you put them in the real world environment, and they're basically learning as they go along instead of being able to solve problems immediately. Same thing is happening kind of in the realm of containers. I think we're going to start seeing managed services take a much larger hold of the market, because of that specialized needs that you and specialized knowledge that is going to make these highly complex systems work together. And I also see the folks that provide managed services on these types of solutions are getting much more aggressive in staffing up, and also kind of conceptualizing what their services will offer, and also bringing to the table kind of the hey, you're better off letting us do it than trying to do it internally. And they're making that a salient point by just talking about all the failures that are out there. You have a lot of people that go through containerization, and they start off small and they start to scale, and things are working good until they get to that certain tipping point where things are out of control, or they no longer work the way that they need to, or they no longer support what needs to be done. And when businesses get to that level, they're going to have to turn to that outside help. And then the decision is going to be made, hey, do we shift this all off to a service, or do we bring consultants in, or do we try to internalize everything to solve that problem? And 9 times out of 10, it's going to be that service offering that gets you going a lot quicker. Although there will be that migration or those other factors that you need to move into a service orientated container infrastructure. And but what you run into with these folks out there is that they've done this before. They've done these migrations. They've done things like that.
Mhm.
So, they bring additional skill to the table. So I think we're going to see, a revolution of outsourcing, at least in the near term when it comes to containers. And we're going to see that go up, more and more outsourcing. Then we're going to hit a certain level. Then we're going to see it go down, like we've seen happen with so many other technologies. As the market gets more mature and more people know how to operate that, people move back from that external service model to try and internalize it. And I could see that happening with containers, you know relatively short term, within 3 years, 4 years.
All right. Well, let me ask you about service meshes, right? Because the history of IT is littered with the same thing, right? It's we create something that's too complex. Batman, we need another layer of abstraction to make it easier, right? So we've been doing that for forever. So the latest flavor of that is this notion of a service mesh, which is, somehow or other, I'm going to put this um, management plane above all this network stuff that's programmable. I can maybe get at it from a console, or I can get at it from, a CLI or an API or an SDK or whatever it is I care to use. Is that going to change the way we think about container networking? And will that make the whole thing more accessible?
In theory, it should make it a lot more accessible. Now, what happens is that, service mesh sounds like a real fancy term, but really all a service message is a way to, for services to communicate with each other in microservices environments. It's just, I guess mesh fits good because it's a way to, bring those elements together and have them communicate. But there's a lot of challenges underneath that. And what we're seeing is what's going on with these service messages. You've got a lot of people playing in that market. You've got like Console, Kuma, and then you've got some of the big players like AWS with their app mesh. You've also got from the open cloud ideas, the open service mesh, and they all kind of do things in a different way, and they're all kind of tuned to different. Some are tuned towards Kubernetes. There are others that want to kind of create their whole type of layer around everything for it to communicate. And I think service meshes are a solution to a problem where the problem isn't fully defined yet.
Mm-hmm. A couple of our attendees are calling me out here over the exact terminology for service mesh. So they want to note it's side by side in a sidecar. So therefore, it's not quite above, but duly noted. And also, before anybody starts flipping out, yes, we do need to mention Istio and Linkerd as one of the options that are out there. There's a whole religious debate about that particular flavor of those two things, and I think it all depends on where you get started from. To this end, though, will networking become more programmatic? And if it does become more programmatic, does this herald the beginning of where NetOps becomes part of DevOps?
Potentially. I think the goal out there is to make anything with networking programmatic. The whole idea is giving you that level of control, that being able to further divorce the hardware from the equation, being able to customize and design to meet your needs. But again, you have to know what you're doing. You have to have the tools out there that will truly support what you're looking to do. And you have to have the knowledge, you have to have the support from the vendors, or the consultants, or whoever's helping you do this. And it is kind of starting to move into that uncharted territory where it might not turn out to be the best way to handle things, because complexity could grow exponentially as you throw more requirements at it. So it is something to watch. And when you put all of this together, when you start looking at microservices, service messages, how networking is very, very different in the cloud native era. When you look at, all of those different elements you have to worry about, whether it's, scalability, isolation, security, service discovery, and of course the hooks for observability, and then the tools for um, management and monitoring. And then, of course, we've got the whole concept of how much automation can be involved.
Mm-hmm.
Ideally, if you can program what you want to do at that networking layer, and program it to stay dynamic with what's happening out in the cloud or the connectivity, automation is going to become very, very important. And it's going to be more complex. It's going to be much more dynamic. Workloads are going to change. Come up as they're needed, go away as they're not needed. You're going to have changes in your microservices architectures, and so you got to make sure that meet those needs of being agile, secure, and being able to have the hooks in for automation. Otherwise, this stuff's just going to blow up.
Mm-hmm. Well, maybe, and I think one of our attendees is raising this flag, but are we fighting yesterday's war when the whole war is changing in front of our very eyes, because we're starting to see the rise of this eBPF thing? And, so suddenly the processing of networking and storage and security, for all that matter, is going to be deeper into the kernel. And part of the complexity stems from trying to manage networking up in the user space is hard enough. So, maybe everybody should take a big giant pause and wait for this eBPF thing to play out, or what's your thought?
Well, eBPF scares a lot of people, that are in this field, because they've become, I hate the word comfortable. They've become comfortable with the complexity that they expect to deal with,
All right,
especially
wait,
when it comes to.
I gotta cue the Pink Floyd music now, right?
Oh, yeah, they're comfortably numb. That's good. But eBPF really kind of changes the whole game. And if you're looking at what's promised by it, the whole game is going to change, and it will make things simpler. But we've heard that before, and in the smaller test cases, and the smaller proof of concept cases, it's kind of worked out, but there's still things that are missing. And, you're going to have to take that into account. So, when you start getting in and start talking about like, rootless Docker and things like that, how is it going to address that? How is it going to work with static IPs internally versus, external IPs? So it's going to be one of those things to keep an eye on, but I think very much we are still fighting yesterday's battles because everybody's living in the past right now when it comes to, especially, Kubernetes and Docker. They're
Yeah.
looking at, all right, there's small evolutionary steps, but this is how it was done in the past, and that's what we're sticking with.
All right, but so it's like the man said, though, the future's here. It's just unevenly distributed, so it's coming. And I guess, the thing I worry about is somebody going to go build some, massive network overlay to wake up one morning and discover that, the whole thing is now obsolete. So that's kind of where I kind of look at this a little bit and say, it seems like inevitable, but the question is when, right?
That's true. And I mean, it comes down to a really good question of, who's going to be in charge? Who's in charge of, these applications that are being networked together? I mean, does that fall into the realm of, network engineers? Is it going to be DevOps engineers? Who really is going to be in charge of this deployment? And you know, you got to throw all these other components into it, whether it's reliability, whether it's performance, whether it's security, and how everything's architected. I mean, right now it kind of looks like the cloud architects are the ones that are kind of taking on that role of being kind of in charge of these application networks, only because of all the cloud technologies behind the scene. But they're going to have to share that knowledge and what needs to be done with other folks, whether it's application developers down to that level, whether it's the security DevSecOps folks, whether it's even the DevOps engineers or the network engineers. There's all these things that have to come together that have to be managed. So who really is going to be in charge of application networking at this point in time?
It's going to be the revenge of the Linux admin. That's it. Right? One of our attendees wants us to shift a little bit of a gear, but it does speak to this whole issue around convergence. And will we see security and networking, the management thereof, converge, become one and the same? The policies will be tied to the network, um, and we're living in a world where we want to have more distributed applications, but how easy is it to actually do that in the age of containers, where the question kind of alludes to this as well? It's like the more further away things get from each other and the more ephemeral they are, the more latency it becomes an issue. And last time I checked, the laws of physics had not been suspended. So how do we kind of deal with this? Is networking in the container world going to be limited to by distance, and what does that kind of look like?
Well, there's a lot of potential answers to a question like that. But, if we roll back the clock just a little bit and we look at, the agile ideology and DevOps, we've seen, DevOps grow into having these different other ops, whether it's NetOps, DevSecOps, data ops. We're starting to see all these, elements of ops being brought under this umbrella. And as that's being done, what we're seeing is an improvement in communications. Well, or at least that's the theory between these different types of ops groups and the desire to work together. And on top of that, what we're starting to see as cloud native technologies, it only makes sense that it's going to become, there's going to be an ops movement here. And because you look at these other drivers behind these ops things, whether it's automation or communications or doing sprints or having pipelines, all that fits well into what we're trying to accomplish now with cloud native technologies and containers, things like that. So I think it's inevitable that we're going to see these things come together under an umbrella, but it's going to be the folks in that are driving this shift left type management that are going to really bring elements together to make it work in this ops type environment. So I think there's going to be definitely a convergence between something like DevOps and NetOps. But the way the roles are going to change, just yet to be seen. How the responsibility is going to be merged together. Um, the greater collaboration part is going to be definitely a benefit to these teams. Integration will be a challenge. And, as long as everybody keeps their eye on the goal of making, things more reliable, more scalable, and more secure, hopefully that'll be the glue that brings, these folks together.
All right. I'm going to try to knock off 3 questions here with some help from the audience on the third one, maybe. But first thing is, as it relates to this particular issue, I mean, you're going to see more data being processed at the point where it is created and consumed. So that is going to introduce some latency issues when you try to access some sort of application that's sitting in the cloud using some sort of microservice that's all magically connected through some distributed cloud native app. So my 2 cents on it is, this is something you may not want to do by yourself, and it's not going to be easy, and it's prone to have lots of risks. So proceed with care and think about it, and don't assume that everything is just magically going to work just yet. That said, the next question is, somebody wants to know a little bit more about what eBPF is all about. And at the risk of a gross oversimplification, it's essentially we're going to be able to run more functions in the microkernel of the operating system, first Linux and eventually Windows. So I don't have to process the networking, storage, and security up in user space. The idea being that I'll get much better scale. Things will generally be a lot faster than they are today. Secondarily, I'll be able to gain more visibility because I can now use eBPF. eBPF is kind of a central point for observability that will allow me to look up the network stack. Networking people have always been telling you that the network is the single source of truth, and there's always been a lot of truth to that statement, but getting at that truth has been hard. And so theoretically, eBPF will make it easier to determine what actually is happening above the Linux kernel layer in a more reliable way. This is all the theory. Can't swear to you that this is all going to work. And then lastly, I'm going to punt on this one, but we have one attendee who wants to know more about rootless Docker. So if anybody has some opinions out there, by all means, join the chat session and throw in your 2 cents as to whether rootless Docker is viable, or because the issue apparently is can't seem to find anybody who knows anything about it. So is the whole world ignoring this for a reason, and should he give up, or is there something more to this? So anybody wants to jump in on that conversation, feel free. Next thing I want to get at is you were talking about networking and security convergence. We see this in the regular world outside of containers, right? We're seeing a general shift of security operations over to IT and networking people. So I would expect that trend would continue even in the age of containers and cloud native. But is there some reason to think that maybe this will become, the last refuge of the specialists for security or the specialists for networking because it is new and complex?
Yes, I definitely think so. Yeah, I think you're spot on with that. It's this level of complexity and how it's exponentially growing. means that people have to become, a lot more specialized in their knowledge, and also have to become a lot more specialized in their practices. I mean, look at the medical field of, 100 years ago. The family doctor did everything, surgery, this and that. Today, you look at it, you've got specialists for everything. And I think we're going to see kind of a move towards that instead of some of these complex environments or challenges being consolidated under a single umbrella. I think we're going to need specialists to solve problems that were unanticipated. And as we add complexity to the mix, we're going to see things crop up that no one anticipated or expected. And you really have to know, the nuts and bolts of what is going on to be able to even address or solve that. Now, there might be some hope in, generative AI being able to help with solving problems. You feed all the problems in, and you look at how problems were solved in the past, and hopefully it spits out some type of an answer. But still, somebody is going to have to execute on that.
All right. I would be a little dubious of a generative AI answer related to container networking, given the incredible lack of data available to be analyzed as it were. So I got a feeling that's not going to work out so well. We did have a question though about, and this kind of brings up an issue. So microservices and container apps don't live in isolation, right? So some folks have been leaned in on Istio or Linkerd or whatever it is, because it enables networking across Kubernetes environments. But these microservices, as one of our attendees points, live alongside monoliths that aren't going away anytime soon. And service meshes that don't span both might become problematic. We've seen some vendors extend service meshes from Istio out to legacy environments. I think there's at least two that are kind of playing down that path today. But there's others that say we just need a service mesh, that works across both and isn't really designed or optimized for one versus the other, because, they're all just things to be networked together. So I don't know what your sense of the world is, but, are service meshes moving beyond just being a cloud native thing? Do they need to become this new class of networking services? And this is how we're going to manage stuff at a higher level writ large.
Well, Istio is pretty interesting when it comes down to it, because, it is an open source project, which means everybody's playing with it. Everybody's doing different things with it. So if we're going to see it evolve into something more, we just have to keep an eye on what developments are being done under, the Istio project. I think it would make sense to be able to bring, more management and tools and insights and all that into a service mesh, and being able to extend that to be able to look at more elements of networking. So, are we heading towards unified platforms? Well, hopefully, when it comes down to it.
Yeah. I think it's inevitable. It's just a question of whether you're going to get there from Kubernetes out, or if you're going to get there maybe from something that starts more holistically across the entire stacks that you have, and helps you kind of deal with networking at that layer. And I also think it also comes down to who starts the conversation. I think if a cloud native team starts the conversation and they figured out that they want to call some monolithic app somewhere, which is from their perspective a big microservice, then they might say, let's go with Istio and we'll extend it out. Other folks might say, if this becomes run by the network operations team, they might take a totally different point of view on it. So I think that there's a conversation being had within the halls of enterprises about who's going to run the future of these kind of networking services, because you could say to the network ops guys, hey, you're in charge of the switches and routers. Good luck with that, and we'll take care of everything else, right?
It could potentially be that, but there's other factors that can come into play here too, and rootless Docker, for example, we were talking about before. The idea to be able to set up containers that don't need any type of root access, low level access, protects those containers, and it reduces that risk of privilege escalation that you normally have. And you combine that with a service mesh, you're actually kind of building a higher level of security, and that might be one of the drivers behind what the future holds.
Hmm. Yeah, we're starting to see the emergence of yet another term that sits on top of another term on top of another term, but it's called application networking. And I think that's a simpler term for a lot of people to understand, because most people are probably still scratching their head going, what the exactly is a service mesh anyway? But if you just say like layers 4 through 7 are going to represent application networking going forward, and we're going to manage that in some sort of more holistic fashion, and then everything below is the underlay. Is that where we're headed to this conversation? And the means might not be as relevant as much as the capability.
Now, what makes that interesting is, if we turn back the clock a little bit to, before cloud applications were the rage, or computing at the edge was the rage, or anything. We had application firewalls and application load balancers that was done in hardware. You had a device on the network which took into account managing the application layer and everything around it to bring those applications out to a user. This kind of extends on that ideology, and it makes perfect sense. So, I mean, if you build application networks, as it were, you're solving some particular challenges. You're addressing that load balancing issue. You're addressing service discovery. You're incorporating traffic management. You're also giving yourself that observability, and you're building that resilience into your networking where, hey, it's intelligently, the network is intelligent enough about the applications that if something is wrong here, it knows how to, preserve it or bring something else up. It's going to have to be, of course, integrated with service meshes. And it's also going to have to work with the orchestration platforms. So there is a bit of complexity there. But this, in turn, might bring more simplicity to that complexity, because you're focusing on networking the applications and not all the other minutia.
All right. I think this is the networking equivalent of my dance moves are so old they're new again. Is that where we're going with this?
It could be.
So to that point, though, right? So we saw over the last 15 years, networking vendors were investing in SDNs, and they were touting all the benefits of software-defined networking. And there was the whole debate about, networking guys were like, I'm not giving up my CLI out of my cold dead hands and all this other stuff. But the argument was we were going to deliver application services through these SDNs. Is that whole SDN conversation going to get subsumed into this application networking conversation? And, at some point, does, a Cisco and a Juniper have to kind of reinvent themselves now? And who knows, maybe they wind up buying a lot of companies that have Istio expertise. And is this we're all going to just come, full circle?
Well, SDN is all about, separating that control plane from the data plane. When you have an SDN, software defined network, the key word being software defined, the idea is that you're, making the networking portion much more adaptable, which is also kind of what, a service mesh is kind of looking to do by being able to deal with, the containers and the applications underneath. They might wind up being, complementary when it comes down to it. SDNs and service meshes. Um, or, your software defined networking might ultimately just go away and be replaced with something else. It's hard to, really determine where that'll head, because currently, mesh services and SDNs, serve different purposes right now. That doesn't say that they can't be used together. but that doesn't mean that using them together is a wise thing to do.
Mhm.
Um, you can probably, stick right now with SDNs to manage the underlying networking and use a service mesh at the application level. The question becomes, can we bring those two together into something new that addresses both issues? I think it's possible. I think there are definitely people out there looking at doing that, but it will require, some significant changes in how we view, cloud services, the networking under it, and how we manage all of that.
Right. We can see how the vendors might play out this whole conversation, but are we in danger of having political turmoil within the IT organization because different groups will have come at this from different directions, and there'll be, people will be on the one hand trying to preserve control of their fiefdoms, and other folks will be like, dude, I don't want to wait 3 weeks for you to provision a network service, so I'm just going to do it myself.
Well, we have stuff like that going on in the IT kingdom as it is.
Mhm.
There are, the fiefdoms that want things done a certain way. You've got, the Luddites that always, hey, I understand how this works and we're going to stick with this. And then you've got, these new cloud first people coming into the picture. I think it's going to be, a battle internally. And I think obviously the winner is going to be determined by who can prove the best return on investment in the technology, and who also can, I hate to say it, who can potentially reduce headcount in IT by having, better services and more automation.
Yeah, well, to the point that it's always been about some level of automating ourselves out of existence, right? Because that's kind of part of what the tasks or the management is. But there's always some higher level of abstraction that comes along that needs to be managed as a result. So, not too worried about people kind of losing their gigs as much as I'm pretty sure that they'll be redefined.
Hmm.
And it's a question of who's going to be in charge of that and from what perspective and what team, because there's nothing preventing a networking person from joining a DevOps team or becoming part of an application networking team. It's just going to be a different perspective on what they're called and who they report to. But somebody's got to do the function and the job one way or another. Um, do you think, as we go along with all of this, though, that um, we are too attached to our technologies? And I say that because everybody went out and got a certification in something, right? Now they're a Cisco this or a Juniper that and a this, that, and the other. And I kind of look at the landscape these days and go, maybe that doesn't serve us as well as it once did. And we need to kind of step back and say, we're something horizontal specialist, but it doesn't have to be tied to a particular vendor's cert program. It needs to be tied more to just a knowledge and a capability and a skill set. But have we kind of parked ourselves into or backed ourselves into a corner in some ways?
Yeah, I think we have. I mean, there's some certifications that will retain value for some time. Um, for example, certifications on the level of, Linux, for example, Linux administration. Hey, having a certification in that means how to be the root guy for Linux. But, you delve a little bit deeper into these hardware specific and software specific certifications, they're becoming more and more meaninless because
Mm-hmm.
of several reasons. The technology, evolves so quickly that, what does this certification mean, 2 years later? It might not mean anything. And also, you're seeing more and more pushes towards, open source or software defined or things like that. That kind of changes the game as well. How do you get, certified in something that changes constantly, or that is a complete, shift? Um, you know, I think I see certifications going more along the lines back to the basics, like knowing, verifying that what what all the network layers are, or knowing, basic things that are critical to success. The more specialized certifications, I mean, if you're an organization that's heavily like invested in Cisco hardware, and you're going to stay that way because, let's say, you're Cisco, you're going to want to make sure that the certifications are kept up to date and that are critical for things operating. But the days of the one vendor shops, or the Microsoft shop, or the Novell Netware shop, or whatever, I think those days are gone.
Hmm.
And I think we're shifting to, hey, are we a cloud first shop, or are we a traditional data center shop, which will eventually become a cloud shop? And I think that's where we're seeing the changes, where the concepts will be more important than what screws you turn or what buttons you push.
Hmm. Now, yeah, I'm not even sure where you might go get an application networking certification, or if it's valuable beyond the fact that there'll be somebody putting a job posting up someday looking for somebody with 10 years worth of application networking expertise for something that, as a concept, has existed for 6 months.
Yeah.
But that's kind of the nature of the game that we live in. What As we go along, and we put all this together, do you think that there might be a backlash against cloud native and microservices applications because of all these networking issues, and you're going to see organizations go, yeah, you know what, guys, we'll use it when it makes sense, but it's just too hard.
Well, if there's a lot of publicized major failures, then yes. That's what it comes down to. If organizations hear a lot about failed pilot projects, then yes.
Hmm.
It all comes down to that skepticism about the technology. If it advances and it works well in many situations, it's going to come. It's just the way that things are going to be, because it's the new sliced bread at that point in time.
Hmm.
But if there's enough to debate about it, like saying, oh, company A, B, and C, wasted $80 million on trying to do this, and these were all the problems they ran into and weren't able to overcome, you're going to see the old ways of doing things lasting a lot longer.
So, yeah, all right. One of our attendees is pointing to somebody moving from microservices to monoliths in an Amazon internal study, raising some eyebrows. And I think that's part of the conversation we have to have with ourselves, right? Too much of what we get involved with in IT is trendy, fashionable.
Yes,
People
definitely.
are building cloud native apps because it's supposed to look good on their resume, and somebody told them this is how they get their next job. But not all the apps that are running on Kubernetes are fit for purpose by any definition, and some of them probably belong on a serverless framework, and others belong on a monolith, and some belong on some hybrid thing, and that's part of where we're going to see. Um, and if that's the case, then maybe the networking person is the only sane one in the room, because they're going to at least stitching all this stuff together in a way that makes it more cohesive. And is that how we need to think about it? And is the idea of container networking too narrow a thought?
Well, what it comes down to, the network guy is going to be the one that approaches things logically. You know, you they're going to be the ones presented with a destination and a starting point, and hopefully they are the ones that are able to look at all that minutia and say that, hey, for what we're doing here, maybe a monolithic approach, completely internalized in the data center, is the way that we should go. And that reason could be, whether it's performance or synchronization, or even security, or maintenance, or reliability. There could be several reasons behind that. And then they could look at it saying that, all right, it's much more simplified networking approach to make that happen. But
Hmm.
if the question arises that we need to service certain things, we need to achieve particular goals, whether it's on our web store or something like that. They might be the best person to look at how information is delivered and whether or not the networking should take place, and the data should happen like at the edge or, in a
Mhm.
container. And this is how we're going to manage this. And this is how this needs to scale. And they might be, the voice of reason at that point in time. I mean,
Yeah.
as opposed to the executive that watched something or read something in the journal and says, "Hey, we should do rootless Docker. That's the future." You bring it down to the person who has to make the stuff work.
Mhm. And speaking of that, there's another thing coming down the pike already called WebAssembly, which is otherwise known as WASM, which is another sandboxed environment essentially that's a little more secure than in containers. But eventually, somebody's going to have to network a WASM something or other to a monolith and a microservices based container, something else. And um, none of this stuff ever goes away, I noticed, but we keep adding new layers of stuff on top of that. And the only person who seems to stick around is the networking person who probably,
Very
after they're
true.
done cursing everybody out, has a good laugh because they're like job security forever, right?
Very, very true. I mean, this might be all the things that drive this new, idea of service mesh built into software-defined networking integrated, this whole new layer of networking that, touches many different scenarios. Maybe
Mhm.
that'll be the driving thing that creates this new foundation.
I have seen over the years though that once a stack starts to get bigger and bigger and bigger, eventually their forcing function comes to collapse it. And
Mhm.
so I think a lot of the things that today are bought as the point products that I got to implement and stitch together are going to become um, uh, features of something larger, some sort of application networking service thing that's just going to span multiple architectures. But right now, we seem to be keep building the same big stacks over and over again everywhere we go. I think that's going to collapse, and I couldn't
Yeah.
tell you when for sure, but it just seems logically that the size of the stack has become unmanageable.
Yes, yes, it's becoming unmanageable, and as you add another slice to the stack, it becomes that much more unmanageable. And then also, you have to have, for each element of the stack, you got to have a particular person with expertise there. People are out there saying, "Oh, we need full stack engineers." Well, I don't think those exist anymore.
Mm-hmm. Yeah, well, if they do, there's only three of them, and they're all taken, right?
Yeah.
All right. All right, guys. I'm going to hand this back to Cody. I want to thank you for spending some time with us and sharing your knowledge and insights. Honestly, we're at the far edge of the frontier here, so I don't think anybody can say with absolute certainty what's going to happen. And if they do, you might want to look at that with a little amount of suspicion. But we enjoyed the chat immensely. And Cody, take us home. Cody, you're on mute. I cannot hear you.
Thank you for that, Mike, and also thank you
Yeah.
for joining us. Frank, thank you so much for joining us as well. It's always a pleasure getting to hear from you.
Thank you.
I would like to remind our audience that this session was recorded. You'll be receiving an email with a link to access this recording on demand. You should receive that here pretty shortly. You can also find it living on the Cloud Native Now website. Just visit cloudnativenow.com/webinars, and you'll find it living in our on-demand section. The four winners of our $25 Amazon gift card drawing, they are Donna W., Sunil M., Meron H., and Joseph Y. So to our four winners, congratulations. Keep an eye on your inbox to claim your gift card. You should receive it in about the next 48 hours. But if you don't happen to see that, do check your spam folder just in case it gets filtered out. So to our audience, we are at the end of the hour. I'd like to thank you for joining us today. We really appreciate you spending time with us, and we do want to hear your feedback. So as soon as we close out, there'll be a survey that pops up. Let us know what you thought about our discussion right here, or if you have suggestions for future webinar topics, go ahead and let us know in that survey. We'd love to hear back from you. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Mike, Frank, thank you again.